Hello, I'm Michael Eyebrow, and in this video I'm going to give you an introduction to working with motion sensors in iOS. So we're going to be using another new framework for this. In this case the framework is called Core Motion, and it gives us access to various motion related sensors. So an accelerometer, a gyroscope, and where devices have them, magnetometers and altimeters. So first thing it can do is it can tell you which sensors the device actually has. So all recent devices have accelerometers and gyroscopes, and typically magnetometers and altimeters as part of them. But as you go back, older devices don't have some of these, and if you go back far enough, certain devices like the iPhone 3G don't have a gyroscope, for example. So we access all of this via a class called CM Motion Manager. So first of all, the accelerometer. The accelerometer measures force, and it measures it as applied to the three cardinal axes of the device relative to the device. And we have two ways of getting information from the accelerometer. We can either sample it, or we can request to receive it at specified intervals. So when we're sampling, we do this by first setting up an instance of the CM Motion Manager, which we do using the code here. When we want to start getting updates, we turn it on. Now, obviously, turning this on means that you're using the sensors and you're going to be draining the battery more in the same way that we did so when using the GPS, though in this case it won't use up as much battery power. So we want to do this conservatively and only do it when necessary. Then we can just ask the Motion Manager instance for the accelerometer data at any point, which is an optional, so we're unwrapping it via this if-let statement. And then we can just access, say, the X value or the Y value, etc. If you want to receive it at specified intervals, well, you set up an interval, in this case a 60th of a second. Obviously you would adjust this based on your needs. And then we tell it to start accelerometer updates, and we pass it two things here. We pass it a particular queue that these updates will be delivered on, in this case the operations queue, but you could also do this on the dispatch queue or some other place if you wanted to. And the second thing we pass it is a closure, a trailing closure in this case, and that closure gets passed two things. It gets passed two optionals, a data optional and an error optional. Obviously we should be checking that the data optional is valid before we read it, and then once we have, this contains an accelerometer or an acceleration property which has the values, and we can do whatever we want to do with that. In terms of the gyroscope is all about rotation of the device, again as components in three axes. And as before with the accelerometer, we can access it in two ways, sampling or at specific intervals. And this code is going to look almost identical, so I'll run through it pretty quick. The difference is we call a method called start gyro updates, and instead of accelerometer data, this is gyro data, but otherwise this code looks the same. For the specified intervals, again, very, very similar. It's just a different method and different property name. This is gyro update interval and start gyro updates. And the property that we read out of the data object is rotation rate. Be aware, I should have said this for the accelerometer one too, just because you request updates at 1/60th of a second, if the app is busy or doing other things, it may not deliver them that fast. So just be aware if you're using this and you care about the timeliness of this, you can actually check when each of these is recorded. so that you can be more accurate if you need to be. Okay, so I should talk about device motion. So device motion is something that combines a number of the different sensors together to provide the most accurate motion or movement information. And in Apple's own words, this uses what they call Core Motion's sensor fusion algorithms, and it combines accelerometer, gyroscope, altitude, and compass sensors to give the best orientation and motion values. And you use it in pretty much the same way. So what we'd suggest for this is you say start device motion updates, and then you can read the particular values out of the data object. In this case, we're getting the gravity values applied to something, and in this case we can use it to determine the rotation of the device relative to gravity, so relative to it being upright, if you like. And we could use that to, say, transform a view so that even as the device is rotated, that view stays upright on the screen. And this is something we'll do as part of the workshops and lab classes this week, so you'll get a chance to see what that looks like on a live device if you don't have one of your own, because this is not something that's easy to simulate on the simulator. Okay, so regardless of which sensor you're using, the documentation says that you should only create one instance of CM Motion Manager. This is because it does a lot of processing behind the scenes, and if you do create multiple instances of it, there's going to be a sort of unnecessary duplication of effort going on, and hence the delay in data rate when retrieving sensor data. The other part of this is, as I said, the drain on battery life. If you're not using motion data, you should call the stop methods for the sensors. So if we were, say, using this to keep a view upright, if our view controller disappears because something's pushed on top of it in a navigation stack, there's no need for it to keep doing work and monitoring the position. When the view will disappear, we should tell the core motion manager to stop these updates, and we can do that using the methods that are shown on the screen here. And in general, if you follow these approaches, this kind of sensor retrieval and processing should not really affect device performance. Okay, thanks for watching.